Hello everyone and welcome to our 7th and final lesson. This lesson is going to focus on geometry, so we're going to be looking at perimeter and area of shapes. So the perimeter is the length of the lines that surround a two-dimensional shape, so it would be adding all of these sides together. So in this case, the perimeter would be this 5 here plus this side, which is 4 centimeters because it's 1 plus 3. And then this side is 5. Then this 1 here, the 2 here, and the 4 here. And this is going to give us 21 centimeters. So this is the total perimeter of the shape. And then to find the area of the shape, we're going to be looking at the inside of the shape. So the shape is made up of a rectangle and a triangle. So the area of a rectangle is going to be our length times our width. So our length is 4 centimeters times 5. And this is the area of our rectangle, and we're going to add that to our area of this triangle. And the area of a triangle is base times height over 2. So our base here is 2 centimeters, and our height is 3. It's important to note that when we're looking at the area, this is 4 centimeters times 4 centimeters. So when we multiply them, it's going to be 20 centimeters squared. So unlike the perimeter where the answer will just be in centimeters, the area is going to always be in centimeters squared or meters squared, whatever it is you're using. And we're going to add that to 3. This is also going to be centimeters squared because this 2 is in centimeters and the 3 is in centimeters. This 2 here is not in centimeters. Only the base and height have units. So the final area is going to be 23 centimeters squared. Now we're going to try to find the area of this triangle here. This question is a little bit trickier because we don't know this length here or the height. Because they're diagonal, we don't know the exact number. So instead of using our formula, base times height over 2, we're going to create different shapes, and we're going to try and subtract the areas of shapes to find this area. So if we make a large rectangle here, we know that this side length is 5 and this length is 6. So we know that the area of the rectangle is going to be 5 times 6, which is 30. And then if we split this area into 2 triangles, we know that for this first triangle here, the base is 6 and then the height is 1. And for the second triangle, we know the height is 2 and the base is 5. And then our third triangle here, we know that the base is 6 and the height is 5. So in order to find the area of this triangle in the middle, we're going to take the area of the entire rectangle and we're going to subtract it by the area of the third triangle, the area of the first triangle, and the area of the second triangle. So the area of the rectangle is going to be length times width, which is 5 times 6. And the area of the third triangle is going to be our base times our height over 2. And our area of our first triangle is going to be, once again, base times height over 2. And the second triangle is going to be base times height over 2. So we end up with 30 minus 15 minus 3 minus 5 is the area of our triangle in the middle. And if you were to subtract all of these, you would get an area of 7 centimeters cubed, squared, if it is in centimeters, or it's just units. You could write 7 units squared. Now we're going to try a problem from the Senator O'Connor Math Contest from 2025. So I suggest you guys pause the video and try it out yourself and then come back and watch the solution. So in this question, we're trying to find the area here of A. And if we were to say that this area here was X and this one here was H, we know that the area of A is going to be X times H. And we can find X because X is the entire area minus the 15. And we know here that the entire area is 25. Oh, entire length, sorry, not area. So our X is going to be 25 centimeters minus 15 centimeters, which is 10 centimeters. And now we have to find our height. So we know that this H is also the same here. And we have the area here, and we have the side length. So we know that area of a rectangle is length times width. And we know here our length is 15, and our width is H, and we know our area. So our H is going to be 105 divided by 15, which is 7 centimeters. So now we can find the area of A simply by multiplying 10 centimeters, which is our X, by 7 centimeters, which is our H. So we end up with 70 centimeters squared. Now we have a square with a known area, and we know that there's a rectangle with the same width as the square. So first we can say that we can draw it out. We have a square with an area of 64. And if each side here, we call it A, and they're all the same, we know that our area of the square is A squared. So we know that 64 is A squared, so we can find our A by taking the root of both sides. And so we end up with A is 8 centimeters. So that is the side length of this square. And then we have a rectangle that is the same width as the square. So the width of the square is 8 centimeters. So the rectangle also has a width of 8 centimeters. And then we know that the length of the rectangle is double its width. So the length is going to be 2 times 8. So our final answer is going to be 16 times 8, which is 128 centimeters square. Now, when we have a triangle that has a right angle, the side that is opposite to the right angle is the hypotenuse, and that's the longest side in the triangle. And we can find the length of this side if we know the length of the other two sides using the Pythagorean theorem, which is the length of the hypotenuse squared is equal to the length of both sides added to each other when they're squared. So a squared plus b squared. So to find the area here and the perimeter, we would start by trying to find our x. So we see that our x here is opposite to our right angle, so we know that the x is the hypotenuse. So we can write this equation as x squared is a squared plus b squared, where 16 can be a and 12 can be b. So 16 squared plus 12 squared. And this is going to be 256 plus 144, which is 400. And then to find our x, we're going to root both sides, and so we're going to end up with our x as 20. And we know the perimeter is simply all the sides added together. So our perimeter in this case is going to be 20 plus 16 plus 12, which is 48. And then our area is going to be base times height over 2. So our base is 12 and our height is 16 divided by 2, which is 96. So for the area, we didn't need to know the length of x, but to find the perimeter, we do need to know that length. Same idea for this next one, except now the hypotenuse is the 50. So this x can be the b. So our equation is c squared is a squared plus b squared, or this is x squared. And so we know that we're looking for our x, so we can isolate for it by subtracting a squared from both sides. So we end up with c squared minus a squared. And we know c is 50, and we know a is 40. So we end up with which is 900. And then this is equal to x squared, so we need to take the root of both sides to find that x is 30. And now we can find the perimeter, which is all the sides added together. And we get 120. And then our area is going to be our base times height over 2. So it's going to be our x, which is 30 times 40 over 2, which is 600. So that's how we find our area and perimeter from a triangle. Now we're going to try and find the area and the perimeter of a parallelogram. So in a parallelogram, these sides are equal and these sides are equal length as well. So to find the area, it's the base times the height, and the height is always this perpendicular height here, so this 4. So our area is going to be 4 times our base is 10 plus 3, which is 13. So our area is 52. And it's important to note that when we're looking for the perimeter, this side here is not equal to 4. The 4 is only this perpendicular height here. So we need to solve for these sides. And we can do that using the Pythagorean theorem because we have a right angled triangle right here, and we know that the side opposite is our hypotenuse. So we can find our c using the c squared is a squared plus b squared, and this can be our a, and our 3 can be our b. It doesn't matter which one is which. So we'll have 4 squared plus 3 squared. So our c is going to be the square root, which is 5. So now to find the perimeter, we're just going to add 5, which is this length, plus 13, which is that length, plus 5 again, and 13 again. And this gives us 36 as our perimeter. Now, in this question, we are looking for our side that is x, this one right here. So the first thing that we can do is find this length right here, because we see that this is a right angled triangle. So we know that 13 is our c, our hypotenuse, and we can label this as a, and then this side can be our b. So this time we're looking for our b. So to isolate it, we're going to subtract a squared from both sides. And we know that our c is 13 and our a is 5. And then to find our b, we square root both sides. And we find that our b is 12 meters, since these other sides are also in meters. And looking at this side here, the b, we see that these two parts are equal to each other. These little dashes mean that they're equal to each other. So since our b is 12 meters, each of these parts is going to be 6 meters. So now we can take a look at finding x, because we know this side, we know this side, and now we're looking for the hypotenuse of this smaller triangle here. And since there's a right angle, we know that the x, which is the opposite side to the right angle, is the hypotenuse. So this is our c. And now in this case, the 6 will be the b, and the 5 is the a. So we'll plug in 5 for the a and 6 for the b. And then we take the square root, and this is going to be a decimal around 7.8 meters. And that is our x. For this question, we are looking for the shaded surface, which is this surface right here. And we are told that the perimeter of the entire square, this big one here, is 2 root 3 over 3. And we know that the perimeter is going to be a plus a plus a plus a, which is also 4a. So we can find the length of a. Since these are equal. So to find a, we would divide this. Oh, that's a 3. We're going to divide both sides by 4. So the 4 is going to end up in the denominator here. So we can simplify this by splitting the 4 in the denominator into 2 2's, because 4 is 2 times 2, and then these 2's will cancel out. So we will end up with a being the root of 3 over 6. Now we can see that the area of this triangle is going to be base times height over 2. So looking at this triangle, we can see that the height is going to be a over 2, because this entire length is a and the height is half of a. And we can see that the base is also a over 2. So if we plug those into the equation, we will get a over 2 times a over 2 over 2. And we'll get a squared over 4 over 2. And then we can put this 4 into the denominator. So we'll end up with a squared over 4 times 2, which is a squared over 8. And since we know that a squared is root 3 over 6, we can substitute that in. And then when we're squaring a fraction, we want to make sure to square both the numerator and the denominator. And so here we will have root 3 squared, which is give us 3, and then 6 squared, which will give us 36, all over 8. And we can bring this 36 down into the denominator. And so we end up with 3 over 288. Never mind, we'll split the 36 first. Because 36 is divisible by 3. So if we break 36 down into its factors, we will get 3 times 12, and then the 8 stays. So the 3's will cancel out. So we'll end up with 1 over 96 as our answer. And that will be our area of this shaded region. So this question here is a little bit trickier because there are no numbers yet until you find the actual percentage. So we're working with variables. So we see here that this line right here is the diameter. And we can name the sides of the square as A. These are all the same. And since we know that this is a square, we know that all of these are right angles. So we can use the Pythagorean theorem to write an equation. We know that our D is the hypotenuse. So D squared is going to be equal to A squared plus A squared. So 2A squared. And we can isolate for our A by dividing by 2 and taking the root. Now when you take a root, you can take the root of the numerator over root of the denominator. And in this case, the root of the numerator is going to be just D over the root of 2. So this is our side of the square. Now, the area of a circle is a formula you guys have to memorize, sadly, but the area of a circle is pi r squared, where the radius, which is this r here, is the length of the line from the center of the circle to the side. So this is the r. The r is also this point to here. It can be from anywhere on the circle. So this is also r. So looking at it this way, we can see that the diameter is 2 r's because this is 1 r and then this is another. So the diameter is 2r. And that's something we can substitute into here. So our length of the square is 2r over root 2. And so the area of the square is going to be our a squared, a times a, because a is both the length and the width. So when we're squaring a fraction, we want to square both the numerator and the denominator. So in the numerator, we'll end up with 4r squared, and in the denominator, we'll end up with 2. And this can be further simplified to 2r squared. Now the question asks us to find the percent of the circle that the square takes up. So to do that, we need the area of the square and the area of the circle, which we have. And so the percentage is going to be the ratio of the area of the square over the area of the circle, because this is going to be smaller. And the area of the square is what we found here, which is 2r squared. And the area of the circle is the formula here that you guys have to memorize, which is pi r squared. And as you can see, the r squareds will cancel. So we'll be left with 2 over pi, which if you plug that into your calculator, you will get 0.637. And to find the percentage, we will multiply it by 100% to get 63.7%. So the square takes up 63.7% of the entire circle. And that is all for today. Thank you so much for joining me for our last session, and I hope to see you guys at the contest.